Today we will be solving an integral problem of e to the power x sin x dx. Now to solve this problem, we will be using an important property which is integration by parts. What is integration by parts? That if we have two quantities u and v, so integral of u into dv is equals to u into v minus integral of v into du. Now look over here. So we have u to be equals to e to the power x, and so here derivative of u will be equals to e to the power x dx. Now from this we can see that dv is equals to sine of x dx. Integrating both sides, we will have v to be equals to minus of cos x. Now we have solved till here. Now let's move for the next step. We will be placing these values into the integration by parts. So we will have here in e to the power x multiplied by minus cos x plus integral of cos x. Now since we will have two signs here, so let me just redo it. We will have minus sign because of this here, and integral multiplied by minus cos x into e to the power x dx. Now this minus and this minus will be basically plus. So this one here and this one here will be multiplied, and this will be resulting in the plus. So this will be equals to e to the power x or minus e to the power x cos x. Minus and minus will be plus. Just to simplify stuff for you, let me write this separately. Okay, so this will be equals to integral of cos x e to the power x dx. Now again we have a similar type of problem which we started with, e to the power x cos x dx. Now we will be solving it separately, and we'll be using the same integration by parts which is here. Now let's solve it separately. So integral of e to the power x cos x dx. Here we will be considering u to be equals to e to the power x. So derivative of u will be equals to e to the power x dx. And derivative of v will be equals to cos of x dx. Now integrating on both the sides, we will have v equals to sine of x. Okay, now we will be placing these values in here, so we will have this equals to e to the power x sine x minus integral of sine of x multiplied by e to the power x dx. Once we have made our peace with it, okay, and we will be replacing this value over here, which we started with. So here it will become minus e to the power x cos of x plus. And we will be replacing this entire value over here. So we will have plus bracket e to the power x sin x minus integral of e to the power x sin x dx. Okay, all right, so let's simplify things. Here we will have v minus e to the power x cos x plus e to the power x sine x minus integral of e to the power x sine x dx. Now see here, on left hand side, which is LHS, we have same stuff like this one. So we can shift it to the LHS and we will have, okay. So solving it further, so over here we will have e to the power x sine x dx. This was already there, and we have shifted this quantity, this one, over to your LHS. So we will have here plus integral of e to the power x sine x dx. And this will be equals to the same value which we started with. That was this one. So here we will have e to the power x minus e to the power x cos of x plus e to the power x sine of x. Okay. Now adding these two terms on the left hand side, you will have is equals to 2 times of integral e to the power x sine x dx. And on the right hand side, we will have e to the power x sine x minus e to the power x cos x. Now to solve it further, we will be taking the common terms out. And here we have e to the power x is common, and we will be simultaneously dividing this onto the RHS. So we will have 2 integral of e to the power x sine x dx. On the right hand side, we will have e to the power x in bracket sine x minus cos x. We're dividing this both sides. So on dividing both sides by 2, we will have here e to the power x sine x dx equals to e to the power x by 2 multiplied by sine x minus cos x. That is our final answer.